Hey students, okay, so we are now on section 5.5 and this is simplifying radical expressions, and I would like for you to not use a calculator at all on this lesson or on this assignment, okay? So when you guys see this root right here, this is called a radical sign, and then there's this n symbol that's usually in this little hook. If you don't see a number in there at all, that means it's a square root, is a common root, so we don't write a number in there, but that's called an index. Okay, so this is an index, and then this number that's on the inside means it's a radicand. So if I say over here, example 1, let's look at that one. So on example 1, we have the 3 in the little hook, so that's an index of 3, so cube root. And then the radicand is 27, and we want to find the index, okay? We don't need to simplify because that's not the direction. So guys, the index is 3. On number 2, go ahead and state the index for me, and then 3. Remember, on 3, if you don't see an index, that's something that's very common that we have done all of your life pretty much in math, and that's going to be an index of 2, a square root. Okay, so take a minute, or actually a couple seconds to write the index for 2. Okay, so we have 2 ways, students, to simplify your radicals. First, factoring, right? As you can see, factoring, it's going to come up in every single lesson. So make sure we know how to factor and show up to office hours if you don't know how, so we can help you. Group equal numbers into group size of index. Okay, so what that means is after you're done factoring, and if it's a square root, we want to have groups of 2's. Okay, if it's a cube root, we want to have groups of 3's. Number 3, rewrite using exponents. So if we want to go from square root, we can go to exponents and vice versa. Number 4, simplify anything you can, aka take it outside of your radical symbol. And number 5, anything that's left that doesn't have pairs or cube roots, then it's going to stay inside of your radical. Now, method number 2 says factor using perfect squares, cubes, depending on your index. Number 2, take the root. This should now be outside of the radical. Okay, so if you have a 4th index, that means you need sets of 4 to take it out. Anything left stays inside. So number 4, let's simplify this really quickly. We want to simplify 4 square root of 50. And guys, if you need to hit pause so you can write down the steps here, please do so. Number 4, square root of 50. So the first thing we want to do is we want to break it down. Because it's a square root, we want to break it down into 2 ways, okay? If you can't see that square root of 25 is a perfect number, then you can break it down further to 5 times 5. But if you do see that square root of 25 is just 5, then we can just keep it as 5 times rad 2. Okay, so that's how we do this one. Now, again, if you do not see that square root of 25 is a perfect square, then go further. So we're going to go, okay, break it all down, factor all down to prime numbers, and we want to group pairs together since it is going to be square root. So we got 5 times 5, that goes on the outside. The 2 doesn't have a pair, so that stays inside. So those are the 2 ways that you can go about that. The next example, example 5, says cube root of 108. Now cube root, because we need 3 sets. Okay, your index is 3, so we need 3 identical sets to take it out of your radical sign. So we know 108, students, it's an even number. So I know 2 goes in there, and 2 goes in there 54 times. 2 is a prime number, so I'll circle that up. Well, 54 is another even number, students. So I know 2 goes in there, and 2 goes in there 27 times. Now, if you know 27, students, is a perfect cube, then you can just simply stop right there and write cube root of 27 times cube root of 2 times 2, because 2 times 2 you can't really take it out because there's only 2 sets. We need 3 2's to take it out. But cube root of 27 is 3. So now we multiply 2 times 2, so that will give us cube root of 4. So 3 times cube root of 4 will stay as our answer. Now, but if you don't know 27 is the cube root, a perfect cube, then keep on going. We know 3 goes in there 9 times, so 3 is a prime. 9 is 3 times 3, and as you can see again, we have 3 sets and an index is 3, so it goes outside. either way, your answer is going to be exactly the same. Now, do me a favor and try example 6, okay? Once you're done, write your answer here and then box that up. Now, we always want the positive root known as the principal root unless told otherwise. So example 8, as you can see, we have a negative square root of 64. Well, a negative square root of 64 is the same thing as saying negative 1 times square root of 64. Oops, square roots, I don't need to write the index, times square root of 64. Well, square root of 64 is a perfect square number, so it's now negative 1 times 8. So that's going to give us a negative 8, okay?